Today we're dealing with the binomial expansion. What is the expansion of a plus b to the n? Well, if a is small, like 2 or 3, just grinding out the multiplication is easy enough. But if it's a large number, like 9 or 10, you would want to do something like this. A plus b to the n, we're going to have the binomial coefficient n0. Now, right here is how we generate these things. Nm is n factorial over n minus m factorial m factorial. So we're going to start with n, and we're going to always use that n, and we're going to, on the bottom, 0, 1, 2, 1 up to n. A will be to a power starting at n and going down to n minus n or 0. And b will start at 0 and go in powers 1 up to n. Now, this is the same as the combination of n things taken m at a time, if you prefer, or we could use the Pascal triangle, which is ones down the lead and trailing diagonals, and in the interior, we get these numbers by adding the two numbers that are above it. So 1 plus 1 gives 2. 1 plus 2 gives 3. 2 plus 1 gives 3. 1 plus 3 gives 4. 3 plus 3 gives 6. 3 plus 1 gives 4. 1 plus 4 gives 5. 4 plus 10 gives 10. 4 plus 6 gives 10. 6 plus 4 gives 10. 4 plus 1 gives 5. And we could do the next row. Put our 2 ones, and 1 plus 5 is 6. 5 and 10 is 15. 10 plus 10 is 20. And then 15, 6, 1. Notice the symmetry. They go up and they go down. And that's because the denominators in the coefficients are the same except for order as we go up, as we go down. So we're going to take an example. Let's expand x plus 2 to the 5th. I chose the 5th because it's more than we would normally just run out the old way of just multiplying, but it's not so big as a take-all day. Okay, so what we have is the 5th power, so that's 5 factorial over 5 factorial minus 0 factorial, x to the 5th, 2 to the 0. And this is a 1. 5 factorial cancels with 5 factorial. 0 factorial is 1. Here we have 5 factorial over 4 factorial, which is 5 times 4 factorial over 4 factorial. We get the cancellation. 1 factorial is 1, so this is just a fancy 5. 5 times 4 times 3 factorial, and the 3 factorial cancels, so we got 5 times 4, 20, divided by 2 factorial, which is 2. 2 times 1 is 2, so 20 divided by 2 is 10. And then here, notice that the denominator just reverses order, so this is another 10. This gives us another 5, and here we have another 1. The powers go 5, 4, 3, 2, 1, 0. And the powers on the 2 were 0, 1, 2, 3, 4, 5. So we have 1 x to the 5th, 2 to the 0 is 1. 5 x to the 4th, 2 to the 1st is 2. 10 x cubed, 2 squared is 4. 10 x squared, 2 cubed is 8. 5 x to the 1st, 2 to the 4th is 16, and 1x to the 0, 2 to the 5th is 32. Now, we don't normally write 1x to the 5th or x to the 0. We assume, of course, that x is not 0 because 0 to the 0th power is undefined. So just cleaning up the notation and not showing the multiplications by 1 or the 0 exponent, we got x to the 5th plus 5 times 2, 10, 10x to the 4th plus 10 times 4, 40x cubed plus 10 times 8, 80x squared, 5 times 16, 80x, and 32. And that is our expansion. So it's a very simple process. It's not that hard to learn, and it will save you an enormous amount of time, especially if you got something like 3x plus 5 to the 10th power. So that is a video, and I appreciate if you would hit the subscribe button before you move on to your next video. And thank you for watching.